Hi, welcome to Radom, where you will meet this gentleman. His name is Nikola Tesla. He lived over 100 years ago, and he invented our entire electrical power systems that we use today. He was a major inspiration for the founders of this company. Over here you will see an experiment that he did exactly 124 years ago in Colorado Springs. This is Tesla sitting inside a coil which is over 50 feet in diameter, producing world's first man-made lightning. The phenomenon that he utilized in his devices is called resonance. And this is something that we also utilize in our core technology. Our core technology is patented across the world, over 30 countries with issued patents. And I'd like to illustrate the principle using a mechanical analog, because here I have aluminum rod and I have a piece of rosin, the same one used by cello players. I'm using it to increase the friction between my fingers and the aluminum rod. If you hold the rod just to the right place and excite it, you can hear the natural resonance of that rod that only depends on the material and the length. For example, I can stop it. If I choose a different material, so these two rods are exactly the same dimensions, just different materials. In this case I have brass, and again I will have to increase the friction. And you can hear that the pitch is different, a different resonance. So we can change the materials and get a different resonance. Or we can change the dimensions. I have a much longer aluminum rod. Let's see what kind of tone we can get from this one. Much louder and also lower pitch. So this is the mechanical analog. This is something you can hear, see, but our invention is actually happening in the world of electromagnetic fields, which are invisible, and it's happening in this ring. This is the Cerawave ring, where we figured out a way how to run electrical current through a piece of ceramic that is essentially a perfect insulator. We can run over 200 amperes of current through a ring like this, where a normal coil would melt, and a normal coil requires water cooling, otherwise it will melt within minutes. This ring has 100 times lower losses and doesn't require any kind of cooling. In fact, here you see it mounted in our optical and emission spectrometer fixture. And it goes into a shield so that it can support the plasma through a plasma torch, which is made of quartz. Plasma torch sits like this, and the plasma is created right there in the middle. The plasma is amazing because it's a fourth state of matter at a temperature equal to that on the surface of the sun, 6,000 degrees Kelvin. Any material on Earth would melt. So the special trick here is to make sure that the plasma never touches the torch. If you can see the port here on the right, as we feed the gas into the torch, it creates a swirl, like a little tornado, so that the plasma sits in the middle of the torch, never actually touches the walls. And that way we can sustain temperatures that are higher than any material can handle. In addition, by changing the material, right, here we have one type of material, one dimensions, but we can make rings using different ceramic materials of different size to work at a different frequency. This is important because if you choose the dimensions right, we can use an off-the-shelf device like a Magnetron, or the same one you would find inside your micro oven at home. This is important because these are made in 100 million units and are very affordable, so that we can reduce the cost to the user for a sophisticated piece of equipment like this. The Magnetron serves as the power source and sits like this. It sends the micro energy into the ring. And because the ring is resonant like a radio antenna, or when you tune your receiver, it picks up all that energy, sends it to the plasma with the world record-breaking efficiency. We will see later on our 100 kilowatt torch. Right? So this is 1000 watt, 1 kilowatt, but we have broken the world record, and we are now at 100 kilowatts of plasma power with the microwaves. And our efficiency of going from microwaves to plasma is higher than 98%. Thank you very much. My name is Jovan Jevtic. I'm the Chief Technology Officer and the co-founder of Radom Corporation. If you are interested to learn more, please look at our additional videos demonstrating our technology and applications.